Okay, hello everyone. My name is Marina and welcome to the EDB Postgres and Tools in a Smart City Project webinar. This session is being recorded and will be shared with you afterwards. You are on mute now. You can ask your questions in the Q&A section later on. So let's begin. And I'm giving the word to our first speaker, Hassan. Hi, Hassan.
Hello, thank you, Marina, for the introduction, and hello everyone and welcome. Due to COVID, I'm actually doing this webinar from home, so if you hear any background noises, unfortunately they are inevitable. I hope that won't be a problem this next hour or so. So my name is Hasan Kılıçkaya, and I'm working as a database architect with the Profelis team. I'm here with Caner Okçuoğlu, and he's our project manager from NAC side. Today, we are here to explain who Profelis, EDB, and NAC are, the relationship between NAC and Profelis, what our project is, what are the general and technical aspects of the project, and how we implemented EDB tools on our projects. So, before we start, let's look at the content of this webinar. We have several topics to talk about. First one is about who Profelis is, what Profelis does, what we achieved in the past, and what our team is capable of. Then I'm going to give quick information about Enterprise DB, who is EDB, what are the tools and services EDB got, and I'm going to talk about the relationship between EDB and Profelis. After that, Caner will take over and he will introduce NAC to us and give a quick introduction to their projects and what they do. And then Caner will go through their decision process. He will talk about how NAC decided to work with Profelis. And then he will talk about the project, general information about the project, and what is the scope and how critical is the data. And then next topic will be about the architecture of the cluster that we use in this project. And we will talk about the key concepts, or rather say milestones maybe. After that topic, you will have basic understanding of architecture. But bear in mind that since we have NDA agreements, we can't talk about every detail of the project. So we will give just a quick tour. And the last portion of the presentation will cover which EDB tools that are used in this project. We used a couple of tools to achieve the desired architectural cluster. So we will talk about each tool separately and why we position that tool. So these are the topics of this webinar. Let's start with who is Profelis. Profelis was founded in Ankara in 2007 and mainly aiming to provide innovative solutions by using open source software technologies. In startup days, our approach was to provide economic advantages by introducing open source software to our customers. However, in time, we have shown that the issue is not only cost advantages, but also that open source software products offer privileges in terms of efficiency, performance, and security. In parallel with the widespread use of free and open source software in the world, it started to draw the attention of the organizations in Turkey around the same time. Naturally, during this period, we had the opportunity to show our competence. It was important for us to be a dynamic and fast-learning team. In a short period of time, our team made our brand a trusted consultant company in the sector. We provide consultancy, training, and implementation services to many of our customers, from public organizations to private sector. Currently, we continue our activities with our excitement, just like on the first day, with our offices in Ankara, Istanbul, and Sofia. We have a couple of signature projects that I want to talk about. First, in 2008, we created Turkey's first hospital that fully uses open source code. Then in 2010, we built Turkey's biggest VPN network back in the day. In 2013, we made a Linux migration project named Gibooks, which was quite a large project. It was Turkey's biggest and Europe's third largest migration project. And then in 2015, we created the world's first e-notary project. So with the help of this application, we can use a send tweet as evidence if we need. And another one in 2017, we created a software called SambaBox. And it was an Arge project. SambaBox is a directory and configuration management service. And it's a replacement for Microsoft's Active Directory solution. SambaBox is compatible with clients like Linux, BSD, and Apple macOS. With the help of Web Management GUI, it is administrable from computers, tablets, or telephones. So we talked about Profelis, then let's talk about EDB now. EDB was founded in 2004. Since then, EDB has been involved with Postgres. And since 2008, they are regular contributors to PostgreSQL. And today, they have more than 4,000 customers and more than 3,000 employees worldwide. And they have offices around the planet. They are one of the major PostgreSQL community contributors today. And they are recognized RDBMS leader by Gartner and Forrester. I mentioned that they have a lot of customers around the world. Many of these customers are Fortune 500 customers, and many of them are Forbes Global 2000 customers. And many of these companies are not using Postgres as a site database, actually. They use PostgreSQL on mission-critical databases. They are very involved in open source development of Postgres. Today, they have a lot of members for Postgres development. Some of them are in the core team. Some of them are in the major contributors to Postgres, and so on. So if we come to the relationship between Profelis and EDB, Profelis is a partner of Enterprise DB for many years, and we are actually the first partner of EDB. Profelis is a certified training partner of EDB. We are responsible for the 2-hour flight area. So if you need a certification for Enterprise DB's Postgres Advanced Server or PostgreSQL, you can contact us. From now on, Caner will continue presentation. So Caner, over to you.
Thank you, Hasan. Hello, everyone. My name is Caner Ökçoğlu, as Hasan said. I am working as a project manager in NAC MENA. And first of all, thank you very much for this opportunity and wish to help for all during this pandemic period. Let me start from what does it mean, NAC? NAC means Nippon Electric Company, and we are as a big family with around 110,000 employees and 122 years old, this company. So our main headquarters is in Tokyo, Japan, and our business activities in over 140 countries, and we are grow up day by day. So we are working for many sectors as a global system integrator and hardware provider, same as professional display and LCDs. Our main solutions are IT and telecommunication, IoT, national projects, smart cities, and many others. We have 65,000 patents about hardware and software. Can we skip the next slide, please? So regarding to our mid headquarters, we are in MENA region, more than 61 years and 26 countries. We have an office in Istanbul and Ankara. Our headquarters responsibility is starting from Morocco, Algeria, Egypt, Tunisia, Iran, Iraq, and Turkey. Also, some CIS countries under our responsibility. If you would like to contact with us, Profelis can help you. Next slide, please. So about how we decided to work with Profelis, Actually, it was not a difficult decision for us. Let me talk about the Smart City project. All Smart City project has many sub-projects, such as garbage collection, traffic light management, transportation, car parking management, and many others. All time, we would like to be focused on our main project. But in other hand, database is much more important point in our projects. Therefore, we cannot reckon without from big picture. The similar project required live big data and process in real time, and the data is so critical. For sure, the critical and huge database architecture need to have professional services. Therefore, our path crossed with Profelis, and we believe Profelis experience and professional services quality. Thank you to Profelis because we didn't mistaken about our decision. And one more big thanks to my team for hard effort during this project. So let me start to talk about typical project detail in next slide. Next slide, please. So so about the typical project detail, let me start from transportation project is important one in smart city sub-projects, because typical projects has 15 million transactions per day, and those transactions comes from around 3,000 online buses and 1,500 top-up points at the same time. 24/7 hours operation need to have disaster recovery, and we already established in our all critical project IT infrastructure as a disaster point. This is so important for keeping the continuous operations. This is possible with high availability architecture and enterprise management tools. Between two data center, it means two database, need to have replication without data loss or downtime. And I think Hasan Bey will give you more technical detail. If you have any questions, let me answer during the Q&A section. Thank you very much.
Thank you, Caner. Then let's talk about the technical aspect of the architecture and tools used in this project. When NAC first contacted us, we as Profelis focused on the scope of the project. For deciding the best practical architecture for the project, we collected information from NAC and started thinking about what we can do for it. Since project scope is huge and the data is critical, we needed to decide carefully for the architecture and what we use as tools. After project details taken from NAC, collaborative work created the best practice for the project. So what are the key points? The main key points for this project was, the first one is deciding which database to use. Should we use Enterprise DB's advanced server or should we use Community Postgres? And secondly, high availability architecture. This is the most important one actually, since the project scope is huge and data is critical. We needed to implement high availability architecture carefully because we don't want any data to be lost or we don't want any big downtimes. And the third key point would be backup configuration. Every production system needs a solid backup strategy. So we need to configure backup procedures according to project needs. And the fourth one would be disaster recovery setup. Since high availability is one of the most important aspects of the architecture, disaster recovery setup is a must. So for this, we use two data centers, and one for production environment and another one for disaster site. And the last key point would be monitoring and logging. Every database should be monitored individually. Since we have many nodes to monitor, we need a monitoring and management tool for this purpose. So these are the main key points for the project. Then let's dive into the technical details. In our project, we have two different applications, and therefore we have two database clusters, and they are separated from each other. Each cluster is located in different data centers, so they are not sharing any resource between them. Before we crossed paths with NAC, the project was already developed on PostgreSQL. Since the project is developed on Postgres, we used EDB standard subscription with Postgres community version, and that standard subscription provided necessary tools for us, and that was enough for us. At the beginning of the project, we decided not to use the latest version of Postgres database, which was PG13. Rather, we used the 12.4 version in our project, since it was the latest 12 version back at the time. While we are deciding the architecture for the project, we had some key concepts to cover. We can count them like, first, the database holds mission-critical data. For this purpose, we used enterprise-ready tools to cover, for example, replication, monitoring, and management topics. And then second, the system should be up all the time, 24/7. For this purpose, we configured high availability architecture for the project. When any of the nodes become unavailable any time of the day, we have at least one replication server to handle the failover process. Things like maintenance, disk corruption, electricity outage, etc. is not creating any problem for us, because when any kind of service interruption happens on the system, automatic failover procedures happen in the background, and the system recovers itself from that situation. Since the system should be available 24/7, we implemented an automatic failover process with Enterprise DB's Failover Manager tool, EFM. With the Enterprise DB Failover Manager tools help, we can do things like automatic or manual failover and switchover processes, monitoring high availability cluster, adding extra nodes, removing nodes to the cluster, etc. Third thing is we never allow data loss. We don't want any data to be lost. Data loss is not acceptable in this project because we hold financial data. For this purpose, we needed synchronous replication protocols and high availability tools. With synchronous replication, we don't lose any data while failover or switchover processes are happening, because we know that if we use synchronous replication, each transaction commit needs to wait for a reply from the standby server to continue its life. So when we commit a transaction in our master database, we know that standby also has that transaction. In case we lost the master server, for example, we know that there is at least one synchronous standby server occurring in the cluster. One other important subject is backups and how we manage them. Every production database should be backed up regularly according to firm's regulation and such. And if we need, we should be able to recover that backup to some other server and see if the backup is taken properly. Or sometimes we just need backup for checking all data. For achieving all these, we can use backup, archiving, and restoring options of Postgres and backup and recovery tool, BART. With different backup strategies, we need to decide optimum backup configuration. Right now, we are using BART for taking backups, controlling them, and deleting obsolete ones. BART can take backups from the master server, hold it in backup server, and if necessary, it can transfer the backup to the recovery server for recovering the database in that server. All those things can be controlled from PostgreSQL configuration file and BART configuration file. After configuring high availability architecture, the next step is to cover disaster sites. In our project, we have 2 different data centers for 2 different database clusters. Each uses their own resources and does not share anything. But when it comes to disaster recovery, we used cross-data center replication. Each database cluster has at least 1 node on another data center. So with that architecture, we are using 2 data centers, and each one holds 1 production database cluster and 1 disaster cluster. That disaster cluster's production environment is kept in another data center. So let's put it in this way. We have data center 1, and data center 1 holds the production cluster of X and disaster side of Y. And in another data center 2 holds disaster side of X and production side of Y. With that architecture, we separated production and disaster sites. In case one data center fails as a whole, other data center will continue its life and all the service will be handled from that data center. Since we don't want any data loss, we implemented at least 1 node of synchronous standby on the disaster side for each cluster. So both the production side and the disaster side holds at least 1 sync standby. After high availability disaster side configuration and backup configuration is done, the next step is to handle monitoring and management of the cluster. For easier management of the database systems, we needed management and monitoring tools. For this requirement, we use Enterprise DB's Postgres Enterprise Manager tool, PAM. With the help of PAM, we can control our cluster from web-based management tool, and we can do a number of things like manually triggering switchover or failover processes, deciding metrics and thresholds for the alert systems, monitoring cluster status, logs, and transactions, or taking manual backups if needed, etc. While we are using PAM, for taking full advantage of the tool, we located PAM agent on each database node, and those PAM agents increased PAM tool's capabilities for us. Each database is connected to PAM separately, and each database node can be monitored via PAM. One last thing I want to cover is one of the application development team is using Tableau program. I'm not sure if I'm pronouncing it right. Tableau program for query building. But Tableau program does not support Postgres version 12. Because of that, we used logical replication between PostgreSQL 12 production environment and Postgres 11 test environment, and connected that Postgres 11 environment to Tableau program. So that's everything that I wanted to cover today. Caner, if you want to add anything to that, please go on, or we can go straight to the Q&A section.
Thank you very much, Hasan, for deeply information. I think we can go to Q&A section.
Okay.
Okay, I believe there are no questions yet. We can wait a little bit. Okay, we have a question. How long does it take for installation?
It will take, it's not always the same actually. Sometimes it takes longer and sometimes it takes shorter. It's not all up to us. Since this is a collaborative work, we needed to install some tools and database clusters on the systems, but also there might be a network problems, there might be a resource problems, and there might be a VPN problems. If we skip to that, it won't take too long, I would say. Between maybe 10 days or maybe 12. It's all about the scope of the project, actually.
Okay. Next, is the customer managing the system now, or is still NEC involved?
Yeah, still NEC involved that project.
Okay. How many concurrent users benefiting from that system?
Last time I was checked, it was around 200 or 300. Caner, correct me if I'm wrong, please.
That's right. It's changing day by day for sure, but as an average, you are right.
Okay, thank you. Can you compare EDB with Couchbase? What is the advantages and the disadvantages?
I'm not expert on the Couchbase, so I would rather not answer that question. I don't want to give false answers.
Okay, next. What was the biggest problem and how you solve it in the project?
Well, the biggest problem was, I think it might be EFM's architecture and how we implemented the virtual IPs, the cluster statuses, and the synchronization of the databases is taking some time to time. And we needed to look for the network side, and we need to look how many transactions we got, and is there any lag between them. Those are the main points, actually.
Okay. Is the system generic enough to be deployed in the other cities? I'm sorry.
Yeah, Marina, I just would like to be answer the question actually before questions.
Okay.
The biggest problem is to find the right partner for leave it to all the database responsibility, because as I said to you, this kind of project very critical and a very sensitive project. Therefore, as an NAC perspective, this problem to find the correct and capable partner. And and thanks to we meet to Profelis.
Thank you. Okay, and the next question, is the system generic enough to be deployed in other cities?
I would say it's pretty generic. We can deploy it on any in any other cities. Of course, there might be a slight differences between them. For example, the node cluster size, node count, etc. But it's pretty generic, I would say.
Thank you, Hasan.
Yes, I am already agreed with Hasan. This is quite enough generic, and all the system, not just for database perspective, all the system is possible to adapt it for other cities.
That's great. Okay.
I don't think we have any more questions.
I believe so. Okay. So thank you everyone for your questions. And on behalf of EDB and Profelis, thank you for joining us today. Oh, sorry, we have another question. How EDB licensing was implemented here? You used a global license for all the projects, or you used a bundle of licenses?
I'm not sure about the licensing, but I know that we used EDB standard subscription. Standard subscription means that we are using PostgreSQL community version, and plus we are using Enterprise DB's tools. And then we are not using Enterprise DB's advanced server. That's the only difference between standard and the other licensing option. But I'm not sure. I don't have any information about the bundle of licenses.
Okay, thank you. So we wait a little bit more, maybe somebody else will ask a question. You're very welcome.
Thank you very much for all the participants.
Yes, thank you for joining us, and have a nice day, everyone.